Okay, so what are going to be some of my main entities? Well, the first one, the obvious one, is the book. Okay, so we have a book entity. I'm going to build an ER diagram here, and it's not going to be a very kind of like a puristic, syntactically correct ER diagram. It's a rough sketch, so purists, bear with me. I might make mistakes here, but just to get an idea of what the relationships are between these main entities. Okay, so I have a book, and it has a bunch of properties, right? It has the ID property, it has the name property, and it has maybe a description property, and maybe a cover image property. Okay, and the publication date. Right? These are attributes of the book. Okay, now you have an author entity, which is going to have, I don't know, ID again, and name, and perhaps image. Okay, and now the relationship between these entities. What is the relationship between book and author? The relationship is one to many, many to one. Well, it seems like many to many, right? A book can have multiple authors, and an author can write multiple books. So technically, you have a many to many relationship. So I'm going to have this relationship here be written by, and this is end-to-end, okay? Many-to-many relationship. All right, next, what are the other core entities here? Well, we have the user entity, which is basically the person who has logged in, okay? We can have the ID, and perhaps the name. I'm not sure about the name. Do we need that? Well, we'll have it there. Maybe we can have some feature in the application which greets the user based on the name or whatever, right? So you have the user, okay? Now the user has a relationship with the book. You know, we talked about how a user can mark a particular book as, you know, I'm reading the book or I've read the book, right? So that's the relationship we want to model here. So a user can read multiple books, and a book can be read by multiple users. So again, it's a many-to-many relationship, all right? So I'm going to model that over here with a many-to-many. I'm going to have this be read by relationship here, and then this is also going to be n-to-n, okay? I'm thinking of having one more entity which is going to contain information about the user interacting with the book, a user's experience with the book, okay? So when a user reads a book, they will give it a start date and an end date, when they started reading it, when they finished reading it, what is the rating, okay? And did they finish or did they not finish it, right? Completed, did not read, did not finish, right? Those things. So that is kind of an entity of its own, right? I'm going to call this user book, which is basically what is the information the user wants to register about a book, okay? It kind of models, you can kind of think of it as a property of this relationship between a book and a user, all right? I'm going to make it a separate entity. It's going to be helpful in terms of designing the schema later on. But basically what I'm going to do is create this entity called user book. And this is going to have a start date. This is going to have an end date, when the user started reading, when the user finished reading, what the status is, are they currently reading or not, stuff like that, and then the rating, okay? Now, how is this related? I can make this related to both the book and to the user. Again, like I said, this is a property of the relationship itself. I'm going to mark this as a relationship to the user, but you can kind of think of it as a relationship to the book as well. I think it's more closely related to the user because it's a user's rating about a book. Okay, the user cares about what the user rates about a book. The book doesn't care about what the user has rated because the book possibly has many more, readers than the user has read books, if that makes sense. So it's kind of, I think of it as closely tied to the user, which is why I'm doing this, all right? So again, ER diagram purists, please excuse me. This is probably not technically accurate ER, but this helps in building an application. So hey, so this one, user has a user rating or has given user rating. Let's think of it that way, okay? So one user and multiple user ratings or user books, okay? Because one user rating can only be associated with one user, okay? But a single user could have rated multiple books, okay? And have multiple such user rating entities, okay? So this is kind of a rough ER diagram, and these are going to be the core entities that we are going to be dealing with, okay? So these are the entities, and we will see how to build the schema from there. This is probably a good starting point for us to work with the data. All right, so now that we have this, we have to start looking into how we can make this fit the Cassandra Schema Design, okay? I talked about how Cassandra Schema Design doesn't start with the entity state, right? If you're working on a relational data model, okay, you're trying to build a schema for a relational database, you kind of take this and you transform it into tables, okay? Because again, when you're building for an RDBMS, when you're designing a schema for an RDBMS, you don't think about the app. You think about, okay, what is my core essence of the data? And then this gets transformed into tables. And then the app later goes like, okay, now here is a table state. Now how can I get the information that I want, right? It's that direction. But with Cassandra, it's the opposite, okay? You're gonna start with the app and identify what are the common user requirements, what are the common application requirements, and then build from there, right? So here's what I'm gonna do. I'm going to identify those application requirements. What are the queries that the app would need to perform? Okay, this is common in Cassandra Data Modeling, right? You look at it from queries. So here are some common queries that we need the app to perform. The first query is given an ID, fetch the book. Okay, so I'm going to call this books by ID. So you're given a book ID and you want to fetch the book itself. This is for the use case of one page per book. Okay, you have a URL where you go something like your application /books/book ID, and I want to fetch the book. And again, this is going to be fetched from millions and millions of books that we're going to store in this database. So we want this to be an efficient query, right? We want to build the Cassandra schema so that fetching a book by a given ID is super fast, right? This is the first query. The next query is the author, right? Somebody sees this book. Now they want to click on the author name and find out all the other books by this author, right? So I'm going to call this books by author ID. You're given an author ID and you want to find all the books written by that author. So I'm going to call this Q2. Now from here, user can click on one of those books and go to the details of that book, which is basically this query over here, right? Which is Q1. Okay, people can go to the author page and then go to a book from there, right? And of course, people can go to a book and then click on the author name, and that's Q2 as well. So if you design a schema to get books for a given ID, and you design a schema where you can get all books by a certain author. Now you have built a system which makes this very efficient, right? You can go to a book, click on an author, see all the books by that author, and then go to one of those books, see if there is another co-author there, click on that name and go on. So you basically accommodated that whole browsing and rendering of those pages fast by building a schema, designing a schema to make this efficient. Okay, these are the core queries that you want your application to be efficient with. Okay, so 2 queries we have identified. Let's look at something else. This is for the no login scenario. Like the user is not logged in, they're just seeing the book, they're just seeing the author, they're just browsing. You're just passively, right? They're not getting any personalized information. But when somebody is logged in, they also need to get their information. Like let's say they have read a book, okay, and they've rated it as 5 or 4 or whatever, right? You need to get that information as well, okay? So you need to get the user book information when somebody has logged in, right? We saw the user book entity over here, which is this guy. You want to get this when somebody's logged in. So how do we do that? So I'm going to create one more here. It's going to be another query, which is going to be called user book by book ID and user ID. Okay, we are going to get for a given user and a given book, what is the user's rating and what is the user's metadata about that book. So this is going to be Q3. When somebody has loaded a book, we want to get the information about that, about the current logged in user's interaction with that book. So this is going to be another query that we're going to have. All right, so this is Q3. And then finally, we talked about a home page. When somebody is logged in, we want to show them the last 50 books or 20 books that the user has read. So this is basically getting user books by the user ID. Okay, we want to have all the recent books that the user has read showing up as a single query. Okay, so I'm going to call this user books by user ID. And this is going to be Q4. Okay, this is going to give you just one book. Okay, given a book ID, you're going to fetch the user's information about that book, user's rating about the book. Okay, given a user ID and a book ID, give me the user's rating. This one is going to be all the books read by a user. Okay, this is going to include the rating as well as the book ID, the book name, and all that stuff. Right, so this is going to be a little different. So it's a list, whereas this is a single book. Okay, from here, from the list of books that the user has read, user can possibly click on one of those books and get that book information, right, which is Q1. Again, you're going to get the ID of the book, and then you're going to go from there to the book information. Okay, and from there you can go to the author, so and so on, right? So this is how the queries and the navigation between the queries are going to work. All right, this is important because now we have established what are the top queries. Well, these are essentially the only queries that you need for your application, right? As long as you build a schema which addresses these queries, you're good to go. Okay, and again, I want to highlight the fact that we are building a schema for the queries and not building the schema in the ideal state of the data. We don't care about what the ideal state of the data is. We don't care about normalization. These could potentially be multiple tables, and we could potentially be duplicating data all over the place, but that's totally fine with something like Cassandra. Actually, it is expected. We don't want to have completely normalized data where you're optimizing for efficiency in how the data is stored. No, we don't care about how the data is stored and how efficient that is. We care about how efficient it is to fetch the data, which means you're basically duplicating the data to make sure that every fetch you need, right? Every one of these queries is basically just one lookup, right? So we're going to prepare the data up front and store it so that when we need to fetch it, it's basically just one lookup rather than having to do joins and all that stuff, which is not possible in Cassandra anyway, okay? So this is what is going to inform how we build our tables, all right? Each one of these are going to correspond to tables. All right, so let's look at how we're going to do that next. We're going to start with the books by ID. We need a table where someone can look up a book by a given ID. All right, that seems simple enough. I'm going to create a table called books by ID. Okay. And what I'm doing here is something called Chebotko diagram, all right? Chebotko, I don't know how it's pronounced. It's Chebotko diagram. What this does is it allows you to kind of have a rough idea of what the Cassandra tables are, and identify what the keys are, what the sorting order is, what the clustering column is, and all that stuff. So it's kind of like transform. You can easily take this and transform it into actual Cassandra tables, okay? So I'm going to start out with the book ID, which is going to be the primary key. Okay, the book ID is going to be the primary key. I'm going to mark it as K. So I should be able to look up a book by a given ID, all right? Now, all the other attributes of the book will show up over here. So what are the other attributes? You know, we've got the name, description, cover, date, and all that stuff. Okay, so all those are going to go as properties or columns, so to speak, of this table. All right, so I'm going to have name, description, cover, and then author name. Okay, I'm not going to have an author ID here. You remember, this is not normalized storage, right? If you're working in a SQL, a relational database, what you would do is you would create an author ID here and have it refer to a relational, have it a foreign key and refer to a primary key on an author table, okay? And you want to get author name, what you do? You join the book table and the author table. Well, you don't do that in something like Cassandra, right? You duplicate data, so you don't do the join. You cannot do the join to begin with. So you're going to have the author name here, which is going to be redundant. It's going to be a duplicate, but that's how you do it, all right? So I'm going to store the author name, so I don't have to touch the author table to show a book in a book page, right? All that information should be right here in this table, which is why I'm storing the author name here, all right? So I'm going to put the author name here. All right, next, I need to create a table to fetch books by author ID. So I'm going to do that next. This is all the books written by a certain author. This is going to have the author ID, and the author ID is going to be the primary key. And now I need to get everything else here, right? So I'm going to get the name, the book ID, I'm going to get the book name. And I just realized we're going to have to get the author ID here as well. Why do I need the author ID here? We need this because we want to be able to create a link to go to the books by the author ID. The application makes a query to this guy to get the book information, all right? We're going to show the author name, but then users should be able to click on the author name. So we need information about the author ID to generate that link so that when user clicks on the link, we can make a request to get books by that author ID and use this as the key to fetch this information. Okay, that's the reason why I need this author ID over here, so that you can use this to fetch books by the author ID of the book that you're seeing. Okay, so I need the author ID here, and this is kind of the reason why I need the book ID as well, right? So somebody is looking at all the books by an author, they can click on one book and see the book information. So getting this is going to help the next request be to this guy, okay, and get the book for that ID, which is why I need the book ID as well. I am going to have the cover of the book as well, because I'm going to need to show something in the UI, right? I'm going to have that as well. And what I'm going to do is I'm going to have the published date over here. And I want this to be the sort criteria. I want, when I'm returning books, I want the books to be sorted in reverse chronological order. We kind of covered this, right? When we are at the author page, you want the most recent book to show up first, okay? Now, here's another thing that you do different in Cassandra. When you're working on a relational database, what do? There's no concept of an order, right? When you're fetching data, you just stick an order by clause, and then you're going to order it at runtime, right? When you're fetching it, you're going to order it. And again, these are things, you do a lot of things in the relational database at runtime, okay? But you cannot do that in something like Cassandra because you're dealing with large amount of data. You don't want to do all these things at the very last minute. You want to do all these things up front, okay? So with Cassandra, you can design a schema in such a way that when you're saving data, it ends up saved in an ordered fashion. You can choose the ordering of your table. So when you're fetching it, you're always going to fetch in the right order, okay? So here, and there's a very good use case for this. Published date needs to be an ordering criteria for books by the author ID. When I'm fetching all the books by a given author, I always want it to be sorted by published date descending, right? I want the recent book to show up first. So what I can do is I can get this guy here and make this what's called a clustering column, okay? I'm going to put the published date here, and I'm going to make this what's called a clustering column, and I'm going to make this descending clustering column, descending order for the clustering column, okay? Clustering column is basically a way for you to tell Cassandra, hey, I want the data in this table to be sorted in this order, okay? It's going to be sorted in the order, and so it's going to make this sorted, ready and available so that you don't have to sort it at the last minute, okay? Now that we have seen these two tables, I want to highlight something about how this is managed in Cassandra, okay? The primary key here, what we're talking about as the K, the primary key here, is what's referred to in Cassandra as the partition column, okay? Cassandra is a multi-node database. It's a distributed database, which means that your data is not going to be all in one server, okay? It also means that your data is not going to be in every node of your Cassandra cluster, unless you want to, of course. Ideally, you don't want to. So your data is going to be only in some of the Cassandra nodes. You can enable replication. If you don't want replication and redundancy, you can technically have one data element available in only one node of a cluster, okay? So you don't have all the data available everywhere. Now, how is this data distributed among the clusters, among the nodes in the cluster? Well, the way Cassandra does this is using something called a partition key, okay? A partition key is used to build partitions of data, okay? Cassandra is going to have a bunch of different buckets in which it stores the data, and what bucket contains your data depends on what your partition key is. Each bucket is essentially a partition, right? It's partitioning the data, so to speak. And this partition is present in one of the nodes, okay? Every partition goes into one node. And the way Cassandra does it is using something called, a hash, okay? It identifies a hash for the partition, and then it puts the data in that partition, okay? Every partition goes into one node. So essentially what you're doing by creating a primary key is assigning it to a partition, okay? I don't want to get too much into the details of how Cassandra manages this partition. Again, check out my course if you're interested in learning how it does it. But basically the idea is every time you ask it to store data, right? You say, I have a book information, which is this guy, right? You have the book, you want Cassandra to store it. Cassandra has like 10 nodes or 20 nodes, right? Where does Cassandra store this information? Well, what it does is it looks at the primary key, the book ID, okay? And it's going to run it through a hash function. And then that hash function is going to inform it where the data should go, okay? It's going to transform it. It's going to map it. It's kind of like a modulo, right? So let's say you have numbers 1 to 10, and you want to put it into two buckets, okay, two partitions. Well, one way to do it is by doing a mod 2, right? Odd numbers go to one bucket, even numbers go to another bucket, right? So it's kind of like that. Depending on how many nodes you have in the cluster, Cassandra is going to map your primary key, whatever your primary key is. In this case, it's the book ID, right? It's going to map that book ID into one of the available nodes in the cluster. And then what it's going to do is it's going to put it to that partition in that node, okay? This makes it easy to retrieve as well. When you're saying, hey, give me book ID 20, what does it do? It uses that same function to identify which node has that data, and it's going to quickly look it up, which makes lookup very efficient, okay? So a quick side note about how this actually manifests as where data gets saved in the distributed Cassandra database. But the idea here is this is based on partition. Now, the thing to remember is that a partition can contain just one record, or it can contain multiple records, okay? So in this particular example, the partition key is the book ID, okay? So every time you have a new book ID, it's gonna map it to a partition, okay? And that partition goes into one of these nodes, okay? This is a book ID based partition. How many books will have a certain ID? There's technically only one book which has an ID. That's the reason why it's a primary key, right? You can have only one book corresponding to a single ID. So if you have the book ID be the partition, you're essentially having a partition of one record each, okay? Every book ID gets a new partition, and that partition ID is going to be mapped to one of the available nodes, okay? So this is a one record partition. It's a one data element partition. However, the author ID, which is in this table, this is a multi-record partition. You're partitioning by author ID, and an author could have written multiple books. So let's say an author writes 3 books. Okay, what's the partition key for the first book? It is the author ID, which is 1. What's the partition key for the second book? It's the same author ID. Now we have 2 records in that partition. What's the partition key for the third book? It's again the same. So you have every partition is going to contain as many books as a certain author has written. So it can be just one, or it can be many. Okay, so what Cassandra is going to do here is it's going to again map an author ID to one of the available nodes. Okay, so in this case, let's say author ID 0 to 10, which is going to map to 2 nodes. Okay, all the odd number authors go to one node, all the even number authors go to another node. So if one of the odd number authors has written 100 books, all those 100 books are going to go to one node. Okay, there's no splitting, there's no partitioning among all the books that a single author has written. Okay, similarly, another author has written 2 books, all those 2 books are going to go to the node that was picked for that author ID, whether it's odd or even. Okay, all that is going to go there. Okay, just to get an idea of how this is split. So one of the reasons why I have done it this way, this particular thing, okay, one of the reasons I've done it like this is when I'm fetching an author ID, right, when I'm fetching all the books written by an author, I want to get all the books by reading a single partition. I don't want to fetch, I don't want to hit multiple partitions. Okay, just to get all the books written by an author, because that's one user experience page, right? I would want to load all the books written by a single author, and I want that to be very efficient. So I don't want to hit multiple nodes. So imagine what would have happened if I had made this a key, right? I had made the book ID to be a primary, a partition key. What would have happened there? So every partition would be one author and one book. Okay, so if an author has written multiple books, well, that each one would be a separate partition. So each one could potentially go to a different node, okay, because it's basically splitting the partition to individual nodes. So getting all the books by an author would possibly require hitting multiple nodes, which is not efficient, which is why I don't have this as a partition key, okay? Book ID is not a partition key. I want all the books by a certain author to be in a single partition so that it's all gonna go into whatever node Cassandra picks for that partition. I hope this is making sense. This is a fairly different and complicated topic when you compare it to something like a relational database. You don't think about all those things with an RDBMS, but you have to with Cassandra. I'm not going to go too much into the detail. I think I've given you enough context so that you understand the reasoning behind this. Again, definitely check out the Cassandra Essentials course where I cover all of this in a lot of detail. Okay, so these are the 2 tables, the book ID and the books by author ID. So now let's look at the other tables. What do we have here? We have user book by the book ID and the user ID. Let's see how we would design something like that. So I'm going to have a books book by user ID and book ID, right? Given a book and a user, what is that user's rating of that book? Okay, so this is going to be loaded when somebody is on a book page and they're logged in. Okay, so I'm going to have the user ID be the partition key, and I'm going to have the book ID be another partition key. Okay, again, we're looking at a single node partition here, right? All I need is one record because I'm on the book page and I want to get the user's information about the book. Okay, single node. I don't care about where it gets stored. I don't have the concern of having to read multiple nodes because it's essentially going to be just one record. So I don't care. What I'm going to do here is store all the properties, right? I'm going to have start date, end date, rating, and the status. Is the user currently reading or rereading or not? Okay, so this is the user and book information. All right, and then finally, I'm going to have all the books, recent books read by a user. All right, so I'm going to basically store all the books by a user. Right? I'm going to say books by user ID. Okay, and this is going to have the user ID be the partition key. All right, and again, as with authors and books, you don't want to have to contact multiple nodes. Okay, so you want to have all the books read by a user in one place. So I'm going to have the user ID be the partition key, and I'm not going to have the book ID be the partition key. I want all the books to be together, right? So I'm going to partition by user ID, but then nothing else, all right? All the books are going to be within that partition. So I'm going to have the book ID here, and I'm going to have maybe I can have the rating. So when the user sees that page, they will see the rating as well. It's good to have that information here. Now, the other thing that we talked about is we want to sort this based on the most recently read books, right? The most recently read books need to show up at the very top. Cassandra has a way for you to store time information. You can either store the time or you can store something called the time UUID. Okay, so it creates a UUID, generates a UUID based on time, and you can sort it so that the newer ones come first. Okay, so I'm going to have a time UUID value here be the clustering column, and I'm going to make that descending. So it's descending by the most recently read ones are going to show up at the top. Okay. Another thing I can have, I'm thinking about this now, is maybe have the status, right? The status of whether the user is currently reading a book or they finished reading a book. Okay. So if the user is currently reading a book, it should show up at the top, even if the user has finished reading a more recent book. Okay, someone like me, I end up reading multiple books at the same time. So I end up finishing a book that I started recently. If the book is really good, I end up finishing it. While some books I tend to leave in currently reading state for a long time, right? So you want the currently reading state to be at the top, even if it's a little older. But then at the same state, I want everything to be sorted. So what I'm going to do is I'm going to have one more here, which is the status, which is also going to be a clustering column, which can be ascending or descending depending on what value we store. I can have like currently reading B1, did not finish B2, and then finished B3, and then sort in ascending, which works, right? But basically I'm sorting based on status and then based on the time. Okay, so these are my essentially four Cassandra tables. Okay, so we've got books by ID, books by the author ID, and then books by a given user and a book ID, which is to show the user information on a book page, and then books by the user ID for all the books, okay? So if we were to look at what we have over here, right? These are all the queries that we have, and each one of these maps to a certain table, okay? So what is books by ID? It's Q1, okay? So we have essentially created a table to handle this query, okay? We've created a table just to handle this query. It's going to be a fetch from this table. What is, what's the next one? Books by author ID, which is Q2. Again, we have created a table for it, right? So this is Q2, okay? Next, user book by book ID and user ID, which is Q3, which is this guy. And then we've got user books by user ID, which is Q4. Okay, so these are the tables that we will need in Cassandra. And now we should be ready to start building something, okay? Once we have these tables, our Spring Boot application is basically going to be fetching data from these tables and then kind of setting it up, right? Fetching the data, storing the data, all that stuff is going to happen in the Spring Boot application. I do want to mention here that there's one consideration you need to think about, which is there a possibility to have too much data in a single partition? It's always something to think about when you're building something in Cassandra, okay? So let's take this for example. Wherever you have multi-record partitions, that's something you have to think about. So books by author ID, you are storing all the books written by an author in one partition. Is there a possibility of that partition containing too much data? Well, I don't think so, because an author cannot realistically write too many books, okay? Maybe 100 books, 200 books, that's still fine. It's not an issue, but it's not going to be like thousands and, 10,000s and all that. So that's still fine. So I'm not worried about this. The only thing I'm worried about here is the books by user ID. So there is a possibility that a single user reads a lot of books, okay? I've seen people who read like, a book a day, okay? Or maybe even more than that. So you can possibly have a partition where a single user has read thousands and thousands of books, okay? Those should be a rarity, right? It's not common to have so many books read by a user, and we can have some kind of rate limiting when we feel like some user is being malicious and they're like, it's not, reasonably possible for somebody to have read so many books. Let's say somebody's marking like a book every minute, right? That's not possible. So we can have some application controls to handle that. But in a realistic scenario, like, assuming that you have those controls, it's unlikely that this is going to be a problem. So that's the reason why I'm fine with it for now. If we have an application that's been out in the wild for a while and we have a lot of users being active and we do run into this problem, a common way to solve this problem is to introduce some kind of a data element which allows you to partition it. So for example, you can have a year be a data element here, right? So you can have the year read be a data element, and then have that be a partition key, right? So you're basically having books by a user read in a single year be in one partition, okay? So that allows you to say like, okay, split it. Okay, you read 100 books this year, that goes to one partition. You read 50 books next year, that goes to another partition. That's one way to solve the problem. But then now we have another problem, okay? You're loading the homepage where you're seeing all the books read by a certain user, right? Now maybe like the first top 50 books read by a certain user. So what if the user read only 2 books this year and the other books were read in the previous year? Now, every time you load the recent books read by a user, you're essentially spanning multiple partitions. You need to get this year's partition and then the next year's partition. You're potentially hitting multiple nodes, okay? Because each partition can go to any one of those nodes, right? It's a bucket which can go to any one of those nodes. So because of this reason, it's a trade-off, okay? You typically tend to get the performance part be more priority, and once performance is fine, then you think about breaking down data so that you're not having one partition be overloaded with too much data. With the way things are right now, with this particular schema as such, I don't see this as a problem, which is why I don't want to have the year read be a partition, which is why I don't want the year read to be a partition key. I'm okay with storing all the information, all the books that the user has read in one partition. This is fine, but I'm just calling it out so that if that becomes an issue, this is how you would do it. You add an artificial field there. You don't care about what the year is, the user has read is, right? When for this particular UI element, for this particular query, for this particular page, year is not going to be shown, but you're artificially adding just so that you can partition by them. Okay, is one technique that people follow. But for now, this is fine. This is not a concern for what we're building right here. Just want to call that out. Okay, so again, to recap, a very different approach compared to how you would build relational database schemas, right? You don't look at the data as a pure ER diagram entity relationship perspective and translate that directly to tables, okay? Because if we had done that, what would our schema look like, okay? If we had done that, it would have been something like this, right? You would have a book table, you'd have an author table, you would have a user table, and you'd have user book table, right? The book table would not have the author information, okay? The author table would not have book information. They are completely separate things, and you have to get those two. You would have to do a join, okay? That's how we would work in a relational table. But we don't do that now, right? What we do is we duplicate the data. We keep data readily available in exactly the format we need so that when we are fetching it, it becomes super easy, right? So that's how we design schema in the Cassandra world. So now that we have designed the schema, let's look at having a Cassandra instance, right? Setting up a Cassandra instance. And yeah, let's check that out in the next video.